Welcome to today's lesson. Our learning objective is to review the number system, interval notation, and basic rounding. Our language objective is to explain how to represent the number system. So let's take a look at today's lesson. Let's take a look at today's thinking. What is a set? A set is a collection of numbers or objects. Each object is called an element or a member of the set. The math symbol for an element or a member looks like a backwards E. So defining the set of numbers. When we learn about numbers, we start off with the natural numbers, also known as the counting numbers. The natural numbers mathematical symbol looks like an N, just with two lines on it. And these numbers are the numbers we learn how to count. So we start off with 1, 2, 3, and so forth. When dealing with IB does include the number 0 when referring to the natural numbers. So as we expand our knowledge of numbers, we then learn about the set of integers. The set of integers, mathematical symbol, looks like a Z, double-lined. And here we are talking about all those numbers that we already know, but for each number, we have some positive and negative. The positive integers. So how do I refer to the positive integers? Mathematical symbol looks exactly like the integers, but will have a little plus on top. The positive integers are dealing with all of the positive numbers. So 1, 2, 3, and so forth. So the reason that IB does include 0 for the natural numbers is because they will refer to the positive integers. So if we were to include, talk about the natural numbers without 0, it will conflict the positive integers. So they're kind of like linked together. Then we learn about the rational numbers. The rational numbers, mathematical symbol, Q, solid Q, double-lined Q. And here we're talking about all fractions. So let me just define P divided by Q, where P and Q are elements, are members of the set of integers. And as we grow our knowledge further, we get to the set of reals. The set of reals, double R, these are all the numbers that are found on the number line. And we slowly create our set of numbers in this form. So let's take a look at our next section, thinking. How do we represent an inequality using interval notation? So our focus here is interval notation. We have some sort of inequality. I'm going to read it. A is less than or equal to X, which is less than or equal to B. If we want to represent this number or this inequality using interval notation, I'm going to start off by saying X is an element of A and B, in which A is included, so bracket, and B is also included, so bracket after B. Both A and B are inclusive, which just means that they're included. The next one, we have A is less than X, which is less than B. So here we have X is an element of A and B, in which A is not included, so parenthesis around A, and B is not included. In this case, both A and B are exclusive, which just means they're not included or excluded. A is less than or equal to X, which is less than B. X is an element of A and B, in which A is included, but B is not included. So A is inclusive, but B is exclusive. A is less than X, which is less than or equal to B. X is an element of A and B, in which A is not included, but B is. So here we have A is exclusive and B is inclusive. And two basic ones, X is greater than or equal to A, and X is less than or equal to A. So here we have X is an element of, we're looking at X is greater than A, so A all the way to all numbers that are greater, infinity. A is included, but infinities are never included, so parenthesis around infinity. The last one, X is an element of, here we're looking at X is less than or equal to A, so all numbers that are less than A would be dealing with negative infinity all the way to A. Infinities are never included, and in this case A is included, so bracket around that. Parentheses and brackets just help us determine whether something is inclusive or something is exclusive. We use interval notation when talking about inequalities, some boundaries, and so forth. So we'll see this a lot within our course. So let's practice what we have seen. Example number 1, using set builder notation and interval notation. For questions 1 and 2, write your answer in set builder notation and II interval notation. So we have number 1, the set of all integers between negative 100 and 100. So for I, we're going to say X such that X is an element of the set of integers, comma, and we're looking at our inequality from negative 100 all the way to 100. It says between, it does not say anything that's included, so this is how we're going to represent those numbers. II, I'm going to write my interval notation. So we are going to just write our interval notation using brackets and parentheses. We're looking at negative 100 all the way to 100, and both these values are not included, so just parentheses around them both. Number 2, the set of all real numbers greater than 1000. So I'm going to say X such that X is an element of the set of reals, and we're looking at X is greater than 1000 for our interval notation, 1000 all the way to infinity. And last one, determine if X such that X is an element of the set of integers and negative 5 is less than X, which is less than 6, is a finite set or an infinite set. So we do have two types of sets, something that has an end and something that keeps on going on forever. So for number 1, this would be considered a finite set because we do have an end. For number 2, we have an infinite set because it is going on towards infinity, never ends. So thinking about that, here we have the set of values from -5 to 6, not including -5 and not including 6, this would be considered a finite set. Why? Because we do have an end. We are starting with some value, ending with some value. It doesn't go on towards infinity. And our last piece here, thinking, how do we round to different decimal places? So some basic rounding. The numerical answer to a problem is not always exact, and we have to use some rounding. There are two ways to round numbers: to a specific number of decimal places, DP for short. We can also round up before the decimal place, so to the nearest whole number, to the nearest integer, and so forth. So let's look at our example rounding numbers. Consider the number that has been given. Round this number to 1 dp, 2 dp, and we're going to start rounding. So to one decimal place, we have the number 5,153 point. Now we do want one decimal place value, so here we would end at 4. Two decimal places, so we would have 5,153, but this time we want two decimal places, so we have 0.4 and 5. Why 5? If you remember, we look over to the right. If that number is higher than 5 or higher, you go up. All right, next one, 3 decimal places. So here we have 3 decimal values we want. Round to the nearest integer. If we want to round to the nearest integer, what we want to round to is the nearest whole number. So that would be 5,153. Round to the nearest 10. That means the 10th place. So this kind of taking us back to 4th grade when we learn about rounding. So the 10th place would be 5,100. 10th place would be the 50, so 50. Round to the nearest 100, 5,200. And that's our basic rounding. So keep learning, keep growing, and I will see you in our next video.